for one of our faculty members, Professor Lamb, and the affiliate faculty member in charge of the project is Nicole Thomas.
Hello everyone, my name is Bukesh Kumar. I'm in geology, Christopher, and Nat, and we're presenting Wearable Sensor Technology, sponsored by Dr. Lamb and advised by Nicole. The goal of this project is to create a prototype wearable sensor which can send data to Android application. The Android application is designed to receive data from sensors via Bluetooth that's being processed and will be displayed on the Android application. Our target for this prototype is anybody that likes to do outdoor activities such as hikers, skiing or snowboarders, or in general anybody that wants to get information on their surroundings. The data we're interested in is the temperature, moisture level, altitude, and your location. The basic idea is to have all 4 sensors connected to a microcontroller which processes the data and sends it to the Bluetooth. And then Bluetooth then sends the data into the air where Android application will pick it up. We broke down this project into 3 major parts: the device, sensor devices, Bluetooth connection, and Android presentation. First, we need to build a device that can communicate with the Bluetooth and process the data and send it to the Bluetooth module. The devices that we have is first 3 are the sensors: humidity, temperature, barometer sensor will give you the altitude, and GPS sensor will give you the longitude and latitude, and the last one is the Bluetooth module. So how do they work? They're all powered by the battery source and use I2C bus output channel, where the sensor serializes a bit, and then microcontroller picks up the bytes in 8-byte. And Beyond will tell you about the Bluetooth connection.
So now that we have the Bluetooth, we have the sensor set up, we need a Bluetooth connection in which our Arduino device can send over the information to the Android device. To do this, we use the Bluetooth module that operates at 9600 baud and simulates a serial link. And we also need to pair the Bluetooth device with the Android, so we need to use a unique address method to connect. To do this, we use a method called the public key encryption method, where each of the devices creates a unique key using a specialized function that each of them make. And then they send each other the public keys, and then they take each other's public keys, use it on their own functions again, and create an item called a session key. This session key is the same on both sides and will be used to encrypt the connection so that they can communicate without any interruption. So after our connection has been built, we need to take the data and display it on our Android platform. To do this, first we need to boot the software flowchart for the Arduino device would go from booting up the microcontroller, initializing each sensor is attached to the microcontroller, process each of the data received from each sensor via the I2C bus, and then deserialize it, and then from that we send it out the Bluetooth module for the Android data. So on the Android side, first we have to set up the connection, because it's the master and slave connection in which Android is the master and sets up the connection while the Arduino listens. Then we put it into an input stream where we collect the data coming from the Bluetooth and then store it in a buffer. And then we send the data over to the handler, which is the handler is a class in Java which handles messages and message queues being sent and relays them to other threads in the Android application. And then we take that and convert them into strings and display them on the user interface. Next, Chris will talk about the hardware infrastructure.
Okay, so let me walk you through the hardware architecture. So starting from the far right, there's a 9-volt battery, and next to it is a regulator. All the components use 5 volt, and you have to regulate the input to 5 volt, otherwise it will toast all the components. So otherwise it is pretty straightforward. There's a humidity and temperature sensor, GPS, Bluetooth, and on the center we have our microprocessor. And next is a barometer. The one that I want to focus is on the far left, the backup battery, and this is only designated to the GPS. And the reason is that without the battery for the GPS, it'll take 10 to 15 minutes in order to do the cold boot. But once the battery is on, it'll take only 3 seconds. The reason is that the GPS receives signals from the satellites, and it'll store data. And also depends on where you're at, because when I was troubleshooting the GPS, it was taking forever. It wasn't booting at all. And I realized I was in a basement. And once I was outside the cold air, it was working properly. So for on the center, the microprocessor, easily known as Arduino Uno. And as everyone should know this, this is well known as, so it's used as on a lot of industrial areas. So the next one is a PCB design, and we use a double-layered PCB board. And the yellow line corresponds to on the front, and the orange corresponds to on the bottom. So on the far left is our raw version of the PCB board. Like I said, some of the traces are on the bottom, some of them are on the back. And on the far right is our board that after I started all the components. Some of the components are on the back. The reason is that I want to make more spaces. And next, Matt is going to explain the software.
So let's start with the Arduino side. We have a setup method that just initializes all the sensors and establish a serial connection for Bluetooth. And here, we're just declaring variables for each of the sensor. And we have special characters in there so that it'll separate each of the sensors data, so that when I go on the Android side, I will be able to break out the strings and store it accordingly. On the bottom, you can see the raw data being sent across the Bluetooth module. And there are special characters in there that will let me know where to break it up. So, on the Android side, this method basically stores all the incoming data from the Bluetooth module into an array and send them up to the handler. And the handler will break them into strings and store it on text fields. And text fields are basically just text boxes that will display strings onto the screen. So parsing the messages. So the reason why I had the special character in there is so that when I parse the string, I can find out where new data starts or where it ends. Then I can just use the index of it and mark it in an int. Now that I know where each data locate, I can just break it up into a string, as you can see, humidity and stuff, and store it as a variable. Then on the bottom, it's just simply displaying the text or displaying the data onto the text field. So here's our app. Here is what it would look like when you establish a connection between the Bluetooth module and the Android. You would pair it first in your settings, and then you would connect to the Bluetooth. And this is the main screen that we will display once the connection is made. So you can see we have a simple user interface that would just display the data onto it. And these right here are text field of what I was just saying. Here is the travel data of the GPS coordinates that we gathered by hand while driving from Bellevue to school. As you can see, the latitude and longitude changed. And we double checked it with Google Maps to make sure that it was accurate, and it was. So this is the picture of our final product. On the left side is our prototype. And on the right side is a picture of the app working and displaying live data.
So some obstacles we ran into were the delivery of the parts. Some of the times the sensors would arrive and then we would not have our PCB arrived yet, so we couldn't solder the parts on, or it was just working out a lot of timing issues. And also, on top of that, we weren't too familiar with soldering, as we didn't have too much experience in class, but Chris there had some experience on soldering and relied on him on creating the circuit board. And also, we had some trouble with the GPS because initially we didn't know that it would completely not work indoors. So we were troubleshooting for a while, trying to figure out why it wasn't working. And then on the software side, we had problems setting up the Bluetooth connection because we didn't understand the coding behind it very well. And afterwards, we also struggled with debugging the software because of just Android implementation and the coding. And so in our future goals, we hope to be able to further miniaturize each of the sensors onto a single chip, and making it essentially the size of a cracker. And then also be able to implement further in software Google Maps and be able to plot the data and collect data as we go along. And possibly we can change the sensors out and utilize the Bluetooth connection so that we can just have a standalone adaptable sensor which can collect data on the other side via Bluetooth on your Android device.
And the takeaway we had from this project was mainly like the establishment on the application development. Coming into this project, we had no idea how to develop an app, and Zurich like barely less experience in Java coding. So that was a big thing we learned from here. And time management was another thing where we all have to work on time in order to finish the project. Each individual has their own tasks to do and their deadlines. And troubleshooting, well, somebody's stuck, we have to help each other out, troubleshooting problems and stuff like that. And independent research was a great thing, because usually in course classes you have direction given how to do it. Like this project is pretty much open-ended, you have to do your own research and work your way up. And teamwork, that allowed us to do like all the work together, come together. And we'd like to acknowledge Dr. Berger for allowing us to do the capstone project and do independent research, and sponsor Dr. Lam and Nicole for being there for us every time if we had any questions or anything. And that's it.
I'm not sure how phones get the location, if it's like GPS or like cell phone tower triangulation, but why did you decide to go with the GPS module as opposed to like a phone built-in function to get location?
Primarily, we're just trying to test to build a device which can connect via Bluetooth, and we just picked out certain functions that we might be interested in case you didn't have like a phone reception or something like that, that we might still be able to have a standalone device that we can test with.
Okay, so you didn't pick a build for
It's relatively close because we were on Bluetooth range, so it would still be relatively short. But, yeah.
I guess that was one of my two questions is, would you just like carry this by yourself or like with your, I mean, I carry my phone everywhere, but would you just have this by yourself?
It would essentially be closer to, with further development, it would be closer to like a wristwatch size where we just have an accessory which is attached on you.
Okay.
Careful, like, Wearable. Other questions? If not, thank you. And thank you to everybody for staying for the presentations and supporting the teams. We really appreciate your support. Again, we're done. Thank you.